we go.
Okay, so welcome at this webinar of H2020 NEANIAS project presenting the core service related to the Visualization Gateway. And our speaker today is Ben Kidd from University of Portsmouth. So Ben, please, you can start your presentation. Thank you.
Thank you very much, Eva. So I'm Ben from the University of Portsmouth, as Eva said. Thank you for the introduction. So I'm presenting the NEANIAS Visualization Gateway for some core services that NEANIAS helps provide. So the Visualization Gateway fits into the NEANIAS work plan in the work package 6 core service, which implements the task C4. Which it gives a good foundation for implementing other services like the Visualization Gateway, which is built on here. So the Visualization Gateway was designed with a lot of the same principles as most NEANIAS work packages. So the core services are all service oriented, and this helps with the integration for various degrees of composability. And all of the services that are on the Visualization Gateway embrace and implement the REST design and FAIR principles. So this is findable, accessible, interoperable, and reusable. And they all deploy some microservices which can be hosted on a Kubernetes. So, and they all, as it says here, single responsibility. So they each do one thing and they interoperate between them. So the Visualization Gateway is built on the core services, which is C4. So it's C4.2. So it interacts with the Visual Discovery Framework, the XR Toolkit, and the C4.4 spatial data stores here. So each building block is a fundamental service, and they each helps the other. So the Visual Discovery Framework is a module on top of the Visualization Gateway, and same with the XR Toolkit and the spatial data stores. And the Visualization Gateway aggregates and implements all of these things. I think it's click. There it is. So the Visualization Gateway implements some workflows. So it uses all of the other NEANIAS provided and third-party provided services. So for example, Visivo and Splotch are technically third-party. And then it implements to the NEANIAS core services like AAI, logging, and accounting. And it also does some other things with the AI services and all of this, which I haven't been too involved with during my time. But I will go through the logging and accounting integration, as well as some monitoring services, which I think is AAI, and also the visual discovery components of the Visualization Gateway. So the Visualization Gateway is currently implemented on Jupyter Hub, and each of the hubs in Jupyter Hub, which are basically containers which can run Python code, which can execute whatever you'd like. So in our case, it executes the visual discovery frameworks, so Splotch and Visivo and Atom Space. These are all implemented on Docker containers, which are pulled from the GitLab at spawn. So these Docker containers are stored as Docker files on GitLab, which are spawned by Jupyter Hub, which is managed by Kubernetes. And each of these containers has its own file system, which is pulled down from Nextcloud every time it starts up, or it's a container is spawned, and FileBeat is used for all of the file aggregation and logging and all of that fun stuff. So all of this is obviously orchestrated by Kubernetes, as they are all Docker containers. So there's a FileBeat, Docker, and Nextcloud. Actually, I think Nextcloud works with Jupyter Hub, but they all work together and interoperate like that. So this shows the options on Jupyter Hub for Splotch, Visevo, and Adamspace, and it's pulled from GitLab as Docker files so that they can be started. And here's I'll do a demonstration later, but here's a quick screenshot of the Jupyter Hub demo where you can see the Python code which generates the image, which through Splotch in that case. And it's live for you to go use at visgateway.neanias.eu at your own pleasure. So the logging implementation is built on top of FileBeat. So it stores, it aggregates the logs from Jupyter Hub, which are in other files defined down here in the containers. And these are just a simple text log. And the output of the stash for FileBeat is the aggregator at NEANIAS. So this goes to the NEANIAS logging servers and is aggregated on a dashboard to be able to view. So it's quite simply implemented with a YAML. So yeah, the FileBeat aggregator takes the logs produced by Jupyter Hub, which requires a small modification to the Jupyter Hub startup script, which defines the format that that is best suited for FileBeat. And this just changes the time, the level, the messages. It's quite simple. And then accounting is built on top of this implementation we just saw. So it uses the same sort of log format from Jupyter Hub, and it just implements another logging container within FileBeat. So it uses FileBeat processes to take a log and process it into a JSON structure, which can be received by the NEANIAS accounting servers and aggregated into a nice system screen that you can look through the logs. You can look through, so for example, you can make a login, log out log, so you can log whenever people log in and log out. And these are all accounted for in the NEANIAS accounting system, and Jupyter Hub is on FileBeat. Monitoring is pretty simple because for a service to implement monitoring on Jupyter Hub, all you really need to do is create a token for Prometheus and then submit a SMS ticket, and the monitoring team will take that and do their thing with it. And you just need to submit 2 tickets for the Grandfoot account and the Prometheus account. Prometheus aggregates the monitoring on the Kubernetes cluster, and I'm pretty sure, or the way around, I don't remember. And this one is the service, the online service, to view the monitoring logs. So the use cases for away from implementation a little bit, the use cases for the Visualization Gateway. At the moment, there's Splotch, Visevo, and Adamspace. So these are particle-based visualizations, dimensional visualizations, and spatial data store visualizations. So they're each discrete applications made by either third parties, or in this case, Splotch is University of Portsmouth. And they run within containers on the Visualization Gateway, which then quite simply just runs in a container with an online interface, which is very simple to use, where you can run code against Splotch, and you can run Splotch on the Kubernetes cluster. So you can create these lovely particle-based visualizations. So I have a small, oh, never mind. So Splotch is one of the applications that can run. It supports large-scale data sets of particle-based data. So this is each one of these is a particle, and it can animate it and all sorts. So it can come from any sort of simulation, from space, astrophysics, hydrodynamics, all sorts. As long as it can produce the file format that Splotch takes in, it can visualize it with a high degree of customizability. and it can run on different compute clusters. And this is a small video. I'll mute it, and I think I can mute it. And just so that we can see the first few images that Splotch can create and its use on the gateway, which I will show a bit later in a demo. So as you can see, it just creates custom views of these particle-based systems, which are pre-computed. So it's accessible on the Visualization Gateway to spawn your hub, but that's a demo for later. So, oh, this is video. Oh, my bad. So another one on the Visualization Gateway is Visivo, and it produces these renders. So a bit different from Splotch, but I got them confused. Obviously spawnable from the gateway, as I said, and yeah. So the Atom Space, I've not worked too much with, but it can render spatial data stores in a visualization format that is easy to digest. So an example of this would be this little bit of Python code, which can call Atom Space, and it nicely visualizes your data. So a big plus of the Gateway is that it's interoperable with an open science cloud. So it uses all sorts of open specifications for the implementation of the containers. So it would not be too much effort to add a type of visualization tool. It defines the common security and privacy framework, which the Visualization Gateway builds on again. And it has easy to accessible data sources. So for example, Zenodo is integrated into the Visualization Gateway. So you can pull your test data from Zenodo, which is the public or data platform, and then process it with Visivo, Splotch, or Atom Space within the Visualization Gateway. So this is integrated with the European Open Science Cloud, and it implements some values with their Exchange and their core. So in order to onboard the Visualization Gateway onto the European Open Science Cloud, we have created a provider for the University of Portsmouth plus the INAF, which is in progress. And so the resource in this case would be the Visualization Gateway, which is also in progress. So this is just done through the European Open Science Cloud, and the Visualization Gateway is the resource in this case. So now for the demo, it's pre-recorded just so nothing goes wrong, and I'll talk through it as it plays. So here you see we can sign in to the Visualization Gateway with an account through NEANIAS and a container that we choose, Visivo or Atom Space. And so now what Jupyter Hub is doing is pulling down the Docker image and Docker file from GitLab. And it takes some time because these Docker files aren't very small. So we'll skip to near the end. So it requests the server from, sorry, it requests the server and then it spawns the server. And then it mounts all of your files from Nextcloud. And for example, we'll run demo.ipnyb. So that's just a Jupyter Hub notebook file. And once this loads, it's a variety of pre-written scripts that demonstrate Splotch. This could be run for any of the services on Jupyter Hub. There's a demo for each of them. So there's Splotch, Visivo, and Atom Space. This one, we can just run the cell, which runs a little bit of Python code, which calls Splotch. So now you see the first cell here is running, and that runs dataset 1. And because it's doing a particle visualization, it takes some time to complete. So as you see, it makes a variety of files from different angles. which is defined in the Python code. And then the next block uses a Python library to display the image in a GIF format. So it takes all these images and just ties them together in a small little video. So this one does not call Splotch at all. But what's nice about it is just from your data and Splotch, you can create these amazing visualizations from next to no effort, right? Oh, hello. Let's get back. So once all of the frames for the animation have been saved, Splotch will say it's done, and the next block will execute. And that is the visualization. So it's quite versatile. It's quite simple to use, right? You just write your little bit of Python code that calls your visualization tool with your data, and then it just works, and it creates a lovely little render and visualization. Oh, close full screen. There we go. Hello. Okay, it's gone out of full screen. That's fine. And so that's all that I have today. We have a validation form, which is important to fill out. So you can go through, use the Visualization Gateway yourself, and what if anything's broken, if it was easy to use, the flow of data, the flow of all that. And I can put it in the chat. I think, oh, I don't have it. I'll put it in the chat in one moment, and it'll be emailed to you after this, after we're all done here, just so you can fill it in at your own time, or you can scan this QR code. So that's all for the webinar presentation. If anybody has any questions, if they could ask them at their convenience. How do I open the thing? And thank you for listening.